Yes. In a triangle ABC, G comma H comma S be the centroid orthocenter circumcenter, then AB bar plus AC bar is equal to dash. The very first option is AH bar 2 into AS bar AS bar AH bar plus 2 into AS bar. Now it's an application of the circumcenter, orthocenter and centroid respectively. If I take the figure into consideration, this is midpoint, this is nothing but a circumcenter, this is circumcenter. Now this is A, B, C. Now you construct triangles, and this is an altitude, this is an altitude, you call it as H. H is nothing but point of intersection of altitudes, is nothing but orthocenter. Meanwhile, you draw a median, this is nothing but centroid. Centroid always divides the median in the what ratio? 2:1. Therefore, this is also 2:1. Now, these two are similar triangles. Now, from this, we can write this one as, the proof of this one is very simple. In a triangle ABC, by using median property, AB bar plus AC bar is equal to 2 times of AD bar. You call this as 1. Meanwhile, I can also write AD bar by vector addition. I can write AS bar plus SD bar. AS bar plus SD bar. Multiply on both sides with the 2. This is by vector addition. Vector addition. 2 into AD bar is equal to 2 into AS bar, 2 into SD bar. You call it as 2. After drawing a median AD, we are formed with 2 similar triangles. They are AHZ, GSD, and meanwhile orthocenter, centroid, circumcenter are collinear, and centroid divides orthocenter and circumcenter in the ratio 2:1. What ratio? 2:1. So therefore, from similar triangles, AHG, GSD, AH by SD is equal to HG by GS is equal to 2/1. which implies AH is equal to 2 times of SD. Therefore, 3 into 3 into. Therefore, 2 implies 2 into AD bar. 2 into AD bar in place of 2AS plus in place of 2SD I can write AH. You call it as 4. Substitute 4 in 1. Because what is 1? AB bar plus AC bar is equal to 2 times of AD bar. So therefore, now 1 implies AB bar plus AC bar, you substitute there. Therefore, 2 into AS bar, it's a AH bar. Yes, we have proved the sum of these two sides can be done as 2 into AS bar plus what? AH bar. 2 into AS bar plus AH bar. Once again, in a triangle ABC, G, H, S be the what? Centroid, orthocenter, circumcenter, that is G with the centroid, orthocenter and circumcenter. We have to show that sum of these two sides is equal to dash. Maybe H bar, 2 into AS bar, AS bar, AH bar plus 2 into AS bar. So therefore, in a triangle ABC, AB bar plus AC bar is equal to 2 into AD bar. So therefore, AD bar is equal to AS bar plus SD bar. By vector addition, this median AD bar is equal to AS bar plus SD bar. So therefore, now multiply 2 on both sides. 2 AD bar is equal to 2 into AS bar plus 2 into SD bar. From similar triangles, after drawing a median and after drawing what altitudes, we could get two similar triangles. They are of the form AHZ, next GSD, and meanwhile the centroid divides the what median, the what ratio 2:1. So therefore, this also 2:1. So therefore, by using the ratio of the sides, A, that is HAS by AH by SD is equal to HG by GS is equal to what? 2 by 1. Cross multiply. Yes, AH is equal to 2 into SD. Therefore, 3 into, therefore 2 into AD bar is equal to 2 into AS bar plus AH bar. So therefore, substitute here, we could get AB bar plus AC bar is equal to 2 into AS bar plus what? AH bar. AH bar. Yes, in a triangle ABC, A of 2, 3, 7, B of 2, 3, 4, C of 2, 7, 4. Yes, you can very well observe are the vertices. Are the vertices. 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 Then position vector of circumcenter is dash. Circumcenter is dash. Now I told the very first method is, first you find out AB bar, OB minus OA. This minus this is what? 0. This is 0. It's a minus 3. What's the modulus of AB bar? 3. Next, BC bar, OC minus OB. OC minus OB, this is 0, this is a 4, this is 0. Modulus of BC bar is equal to 4. Next, CA bar is equal to OA minus OC is equal to OA minus OC. 2 minus 2, 0, minus 4. Next, this is minus 4. Next, 3. Then modulus of CA is equal to 5. Yes, certainly you can very well observe 3, 4, 5 represents what? The lengths of the right angled triangle. The lengths of the sides of right angled triangle. If I go to this one is, yes, this is A, C, B. If I go for 3, if I go for 4, it's a 5. So therefore, AC square is equal to AB square plus BC square by using Pythagoras theorem. So it forms a what? Right angle triangle. You know already the angle in a semicircle is what? 90 degrees. The side opposite to 90 will be the what? Diameter, and midpoint of the hypotenuse is a circumcenter. So therefore I can write, so therefore triangle ABC is right angled triangle. So therefore circumcenter is equal to midpoint of AC. So therefore this is nothing but A plus C by 2 is equal to, now this is A, 2 plus 2 by 2, 2, right? Now 3 plus 7, 10, it's a 5. Next 7 plus 4, it's 11 by 2. This is one method. What's the first method? The first method is whenever the 3 vertices are given, how to find out a circumcenter. So now just verify the what? The first you find out the what? Sides. Find the lengths of the sides. Now almost in vectors, almost it will be either equilateral triangle or what? Right angle triangle, 9-10%. So therefore, now you verify this one is, find the lengths of the sides and verify the Pythagoras theorem. If it satisfies, certainly it is a what? Right angle triangle. The midpoint of the hypotenuse is a circumcenter. Circumcenter. So therefore, now I got it. Circumcenter is equal to midpoint of A, C. So therefore, A plus C by 2, 2, 5, 11 by 2. That's the first method. But this method is monotonous. And doing all this A, B, modulus of A, B, B, C, modulus of B, C, C, A, modulus of C, A, all those you have to find out. And you have to verify the Pythagoras theorem, all this. Students, before starting of this such problems, just think for a moment while, has he given in this format? What format? What I am going to spell out now. That format is, you can very well, this is the first method. Those who deserve it, those who like this, you can. Those who do not like this, I tell another method. It's very easy. If you find ease in approach, you can follow. Otherwise, you can follow this. The perception is left to the student what to select, what not to select. So therefore, you can very well observe. You see the format. Now, in all 3 coordinates, all the 3 vertices, x coordinate is same, 2, 2, 2. Therefore, in circumcenter is also 2. Next, 2 y coordinates are same. Next, 2 z coordinates are same. Sir, if all y coordinates are same, you can go by this method. What I am going to tell next method is not at all applicable. I am telling about a particular case. You can take it as a chance. What is that? All x coordinates are same. Then 2 y coordinates are same. 2 z coordinates are same. Next, when 2 x coordinates are same, all y coordinates are same. 2 z coordinates are same. Next, when 2 x coordinates are same, two y coordinates are same, then all z coordinates are same. Yes, same method I am going to apply for this one is note. What is this note? In the given vertices, if first one, if a of x comma y1 comma z1, b of x comma s comma y1 comma z2, c of x comma that is y2 comma z1. Yes, all x coordinates are same, two y coordinates are same, two z coordinates are same. Then I can write circumcenter. Look at circumcenter is equal to x sum of distinct y coordinates by 2. Next, sum of distinct z coordinates by 2. Sum of distinct z coordinates by 2. So therefore, I can write this one as x comma y1 plus y2 by 2. Next, now this is z1 plus z2 by 2. This is circumcenter. Yes, we are in that situation. This situation explains all x coordinates are same, two y coordinates are same, two z coordinates are same. Yes, now I can write x2, 3 plus 7, 3 plus 7 by 2, 5. Next, 4 plus 7 by 2, it's 11 by 2. Yes, as we did earlier problem, the same answer we got it. Followed. Instead of that, if you observe before starting of the problem, before tackling of the problem, if you observe, is the given coordinates of the vertices, are they in this form? Yes, you can avail a facility, comfort, instead of going by finding the lengths of the sides and verifying the outcome on Pythagoras theorem, all those. This is one of the best way of finding that. Followed? Next, this problem suits for this. Now next, the other one is case 2. Second one is if a of x1 comma y z1, next x2 comma y z2, and okay z1 as you please, c of x1 comma y1 comma z2. Then I can write circumcenter is equal to sum of distinct x coordinates by 2, then y coordinate, then sum of distinct z coordinates by 2. Okay, next the case 3, if a is equal to, if a of x1 comma y1 comma z comma x2 comma y1 comma z, next c of s comma x2 comma y2 comma z. Okay, then circumcenter. The circumcenter is equal to sum of distinct y x coordinates by 2, x1 plus x2 by 2, y1 plus y2 by 2, z. These are the cases, applications you are going to get whenever the vertices are given. So therefore, students, before starting, whenever they ask you to find out the circumcenter, maybe in what vectors, maybe in what 3D coordinate system. Think for a moment while before you starting this problem, because if I remove IJK components, it becomes a 3D coordinate system. So therefore, whenever 3 vertices are given to find the circumcenter, so observe is that given points are in this form or in this form or in this form, then you can make of. If you do not want, then you go by what? Come on, find out AB bar, OB minus OA. Next, find the what length, AB modulus of AB bar. Next, BC bar, OC minus OB. Then modulus of BC bar. Next, what? CA bar, OA minus OC. Then length of CA bar. If all length of all the sides are equal, it's an equilateral triangle. In a equilateral triangle, circumcenter is equal to orthocenter is equal to in center is equal to centroid, because all will be coinciding. Therefore, instead of finding, you can apply directly centroid. What's the centroid formula? x1 plus x2 plus x3 by 3, comma, y1 plus y2 plus y3 by 3. Next, z1 plus z2 plus z3 by 3. For what? Equilateral triangle. If it is what? Right angle triangle, means if they satisfy the Pythagoras theorem, then you can go for what? Yes, midpoint of the hypotenuse. Why? The angle in a semicircle is what? 90 degrees. The side opposite to 90 will be the what? Diameter. Therefore, midpoint of the hypotenuse is the what? Circumcenter. You can go by this method. Otherwise, observe, are they given vertices coordinates? Are they in this format or in this format? In this format. This is about what? Circumcenter. The next concept comes about the rotation of a vector. Rotation of a vector. The rotation of a vector about first x-axis, about first y-axis, about what? Z-axis, right? Now let us discuss about the rotation of a vector. Yes, in right-handed system. Now before starting of the what? Rotation of the axis, I go to this one is first rotation of axis in the coordinate geometry. Now if I go to this one is rotation of axis. Rotation of axis. Now if I take small x, small y as origin. Now small f of x comma y is equal to 0 be the curve. Now if I rotate what? The x-axis through an angle alpha in anti-clockwise direction, this is capital X and capital Y. Then look here, in the rotation of axis, if I rotate like this, I am standing in the same place, means my origin is not shifted. Only the direction of me changes, means the origin is not shifted, only the direction of the axis is changed. Direction of the axis is changed. When the direction of axis change without shifting the what? Origin, such a transformation is known as what? Rotation of axis. When this is the curve small f of x comma y is equal to 0, then small x comma y, the small x comma y, small x becomes x cos alpha minus y sin alpha. If it is what? Anti-clockwise direction, you have to take angle as alpha. If it is clockwise direction, you have to take the angle as what? Minus alpha. Therefore, small y is equal to x sin alpha plus y cos alpha. This is the concept I am making use now in what? Rotation of a vector with respect to x-axis, with respect to y-axis, with respect to what? Z-axis. In coordinate geometry, we are rotating through an angle alpha, both x and y-axis. But here it comes in 3D. Now the vector has, say for example, now if I go to this one is This is x, this is z, this is y. If I take this as a what? Vector a bar is equal to a1i plus a2j plus a3k. Now I start. Note the vector a bar is equal to a1, a2, a3, or else a bar is equal to a1i plus a2j plus a3k with a vector. a1 is the component along x-axis, a2 is the component along y-axis or a scalar, a3 is the component along z-axis. So therefore, now when the vector a bar is rotated through an angle alpha in the right-handed system about x-axis, means you are rotating a bar in anti-clockwise direction about x-axis, means you are taking the reference as what? X-axis, which about what you are rotating, you catch hold of in your hand. In your hand there is a x-axis. This is x, this is y, this is what? Z. Now I take x, this is y, this is what? Z. When you rotate, look here, in the anti-clockwise direction, y comes towards what? Z. Z comes towards what? X. So therefore, in your hand, what is there? X-axis there. So therefore, I wrote here already, by using translation of axis, by using rotation of axis, small x is equal to x cos alpha minus y sin alpha, small y is equal to x sin alpha plus y cos alpha. So you catch hold of this x-axis. Now say for example, what is x-axis? Take this as x, this is what? Come on, y. You take this as what? Z. You catch hold of this x-axis. Now rotate a bar towards what? X-axis, means you are rotating y and z towards what? X-axis. Means when you are catching hold of x-axis, the x coordinate won't change, it remains unchanged. What changes? Y and what? Z coordinate changes. So therefore, with the concept of when you are handing, when you are in your hand, when x-axis is there, we have to think about what? Y and z. Let us see. The vector is rotated through an angle alpha in the right-handed system. In the right-handed system, then the new components of a bar when it is rotated about the first one, x-axis, about the x-axis, then about x-axis. Can you see this? So therefore, now a bar is equal to, I will write a1. In your hand a1 is there. Here a1. Now it is a2. This is what? Come on, alpha. Correct or not? It's what? Beta. Like that also. You can also go for like this. Okay. Now a1. Now in your x-axis, in your hand, x-axis there. X component won't change. Now which comes? Z comes first near to what? Come on, x. So therefore, I can write y is equal to same thing. What I wrote, you are very familiar about the arrangement. This arrangement can also be written like this. So therefore, a1 is equal to, now y component is equal to a2 cos alpha This is same as this only. A2 cos alpha, A3 sin alpha. A3 sin alpha. You see, the y is not changing. Y is not changing. So therefore, next z, the z is equal to A2 minus sin alpha, A3 cos alpha, A3 cos alpha minus A2 sin alpha. Therefore, the z becomes x coordinate when compared with what? Ordinary rotation of axis in a geometry. So therefore, so before y coming, z comes and falls on the what? Old x-axis. So therefore, y is not changing. Y is as it is. X component won't change. Y becomes same. Only z coordinate. Z coordinate becomes the x coordinate of rotation. Therefore, it becomes A3 cos alpha minus A2 sin alpha. Next, the second one is about y-axis. Now in your hand, catch hold of what? Y-axis. Y component won't change, only the change in z and x. So therefore, rotate A bar towards y-axis in anti-clockwise direction. So therefore, then I can write A bar is equal to, yes, come on, A bar is equal to, now what happens now about y-axis? This is z. Okay, z is equal to A1. I can write this one as A1 sin alpha plus A3 sin alpha, comma A2. Then what about z? The z becomes A1 cos alpha minus A3 sin alpha. A3 sin alpha. So therefore, now coming this one is, now about, third one is about y-axis, about z-axis, A bar is equal to, now y component won't change, here z component won't change. Now x, what is x? A1 cos alpha, next A1 cos alpha, next A2 sin alpha, next y, that is A2 cos alpha minus A1 sin alpha, this is A3. This concept already we know very well in the what command coordinate system geometry, translation of axis and rotation of axis. The same thing I interpreted. About x-axis, y coordinate won't change, only z changes. That z becomes x coordinate. About y-axis, y coordinate doesn't changes. So therefore, now x coordinate becomes y. Next, z coordinate becomes what? X. Therefore, about z-axis, now x becomes what? Come on, y. And here, y becomes what? X. And z coordinate never changes. This is the concept of what? The rotation of the vector A bar about x-axis, about y-axis, about z-axis. One, if you know that this rotation of axis in geometry, translation of rotation of axis, just interchange in a cyclic order. That's what. After x-axis, about x-axis, y and z are interchanged. About y-axis, z and x are interchanged. About z-axis, x and y are what? Interchanged. Which comes and falls on the what? Old x-axis, old y-axis, old z-axis. That you have to see that. This is about the rotation of a vector A bar about x-axis, about y-axis, about z-axis. Followed? The last concept in the addition of vectors, by using the definition of collinearity of 3 points whose position vectors are A bar, B bar and C bar, when it is expressed in terms of a linear combination like this, means now I go for let OA bar is equal to A bar, OB bar is equal to B bar, be the position vectors of capital A, comma B, comma C, and C of C bar be the point which is collinear with capital A, comma B, and OC bar is equal to LA bar plus MB bar. Then under the different conditions, I must know the position of C. Means, say for example, if I take like this, O, this is A of A bar, this is B, it may be like this, C may be here, maybe on this line, means this is B, this is B, C may be collinear with this, means when it is collinear you can express like this. But he gives under different concept, different conditions he gives. When he has given under the different constraints or conditions, I must know the position of C with respect to the triangle OAB or angle OAB. Angle OAB. So therefore, if I take like this, right? Under the different conditions, I have to find out. Case 1. If L is positive, M is positive, and L plus M is less than 1. Then I say C lies inside the triangle OAB, I tell. So therefore, inside the triangle OAB, maybe here, inside. I don't want to take here, it may be like this. Instead of joining these two, it may be inside the triangle OAB, like this. Now if I go for case 2, L positive, M positive, L plus M greater than 1, C lies outside the triangle, outside of triangle OAB, but inside angle AOB. Inside angle AOB. Let us see. Case 3. If L negative, M positive, L plus M less than 1, C lies outside of the triangle, but inside of angle OAB, like this, OAB. Now case 4, if L positive, M negative, L plus M less than 1, C bar lies outside the triangle, but inside angle OBA. Case 5, if L positive, M positive, L plus M is equal to 1. I told already in the what? The vector equation of a straight line R bar is equal to 1 minus S into A bar plus SB bar. It represents a line equation. Line means what? Collinear points. It is also same only. Therefore, then C bar lies on AB, but It's an internal point. Now case 6. If anyone of L comma M is negative and L plus M is equal to 1, then C lies on AB, but external. Case 7. If any one of L comma M is negative and L plus M greater than 1, then it is not possible to find the position of C. Now let me explain. Then I give some counter examples, then you will satisfy. As it is, you will be having what? Some abstract idea about this. Now you know already what's the vector equation of a straight line passing through 2 points A bar and B bar. R bar is equal to 1 minus S into A bar plus SB bar. Yes, 1 minus S equal to put L. S is equal to put what? Come on, M. Yes, come on. R bar is equal to L A bar plus MB bar. Or else R bar is equal to, take it as C bar, take it as OC bar. OC bar is equal to LA bar plus MB bar. Is it not a line equation? Line equation means what? They are collinear. What is line? Locus of collinear points. Locus of collinear points. Followed? So therefore, now what I want to do is, now I have taken, this is what? A, this is A, it's a B. Now, if L greater than 0, M greater than 0, L plus M less than 1, C is inside. C is inside. I will give the example at present. So therefore, if L case 2, L greater than 0, M greater than 0, L plus M greater than 1, C lies outside of the triangle AB, OAB. This is OAB, but inside the angle O. This is B, angle AOB, like this. Followed? In this angle, the C will be there. Next, if I go for L less than 0, L is a coefficient of A bar. L is a coefficient of A bar. So therefore, opposite to angle A, M is negative, here L is negative, M is negative, L is negative, M is positive, L plus M less than 1, C lies outside, but opposite to, but inside the what? Come on, angle OAB here, this is a OAB here, this is the position of a C. Followed? Next, L positive, M negative, L plus M less than 1, but it lies outside the triangle OAB, but inside the angle OBA, this one here, in this maybe here, correct? This is the position of C. Next, if I go to L positive, M positive, L plus M is equal to 1, you go to what? R bar is equal to vector equation of a straight line passing through the 2 points, A bar and B bar, is what? R bar is equal to 1 minus S into A bar plus C bar. Put what? L is equal to 1 minus S and M is equal to what? Come on, yes. L plus M is equal to what? 1 only. S and S get cancels. Therefore, C lies on the line. If both are positive, C may be here. Followed? It is on strictly on the line. If anyone is under this condition, if anyone is negative, if anyone of L comma M is negative and L plus M is equal to 1, C lies on AB but external to what? AB. Maybe here, maybe here. It's a collinear, I do admit. It's a collinear with what? A comma B, but it's an external point. Got it? So therefore, now this is next case 6. If anyone of L comma M is negative and L plus M is greater than 1, it is not possible to identify to find the exact position. To find the what? Position of C. The exact position of C. Rather, it is better. Exact position of C. Exact position of C. Followed? So, therefore, now with this concept of what? Common collinearity, let us find one or two problems. This is a questionnaire. Okay? Just if you know, who knows this concepts very well, you can do it in the fraction of a second. No, we don't want this method. We want to go for still analysis, means we can give one or two problems as example. Followed? Right. Look here, boys. What are the discussions I made in the concept, above concept? They are the options. How? C lies inside the triangle OAB. Second option, C lies outside the triangle OAB. When inside the what? Angle what? Come on, AOB. Next, C lies what? Outside the triangle OAB. Next, C lies inside the angle what? OAB. Next, C lies outside the triangle what? OAB, but lies inside the angle OBA. Same options. Same option, you can take it. And I have given what? 5th, 6th, 7th also. It depends upon the questions, right? Yes, now I have taken few examples to interpret the given concept. Okay, now try to think about this. Now, so if I draw this one is OC bar, yes, OC bar is equal to, now you take 3A bar plus 2B bar by 6. You see, when does the geometry fails? When the geometry exists, now you can, by geometry, you can identify the position of any point, the position of any point when its ratio is given. If the ratio is not given, either it is a midpoint or what, some ratio point or trisection point, then only you can identify. When the ratio is not given, certainly the geometry fails. Now if I simplify, now 3A bar plus 2B bar by 6, we don't know what's the ratio it divides. What you have to do? You have to write according to the numerator in the ratio form what you know. You don't worry about this. Now what I write, this is 3A bar plus 2B bar by 5. Why? MB bar plus NA bar by M plus N. What is M? Okay. What is M2? What is your N? 3. M plus N 5. We know this position because this is the position vector of a point which divides in the ratio what? Come on. 2:3 internally. So now I take this as OP bar. But in compared to this, by 6 means certain this value will be less than this. So therefore this is less than this. Why you wrote like this? Because I must know the position of some point to compare with that point. I do not know what's the exact position of that. So therefore now this point divides in the what ratio? That is a 2:3 ratio, correct or not? OP bar. You can very well observe, you draw a triangle. This is O, this is A, this is a B, correct or not? This is the triangle. Like this, like this, like this, okay, like this. This is. Now, yes, now L is equal to how much? L is equal to 3 by 5. Yes, come on. M is equal to what? 2 by 5. Greater than 0, greater than 0. What is L plus M? 3 by 5 plus what? Come on, 2 by 5. Correct or not? 2 by 5. Yes, now certainly, now this is equal to how much? This is a 1. This point lies. Which point lies? P lies. I am talking about the ratio of P, not E. So therefore, since its position is less than this, so it will be like this somewhere. So therefore, now this is a C. Now you can very well observe. You go to the first option. What's the first option I have given in the concept? L positive, M positive, come on, L plus M, correct or not? L plus M. So therefore is equal to 1, correct or not? So therefore the given point here by 6 is there. 3 by 6, 5 by 6. If you want to go for what? 3 by 6 is given. If you go for 3 by 6, 3 by 6, next 2 by 6, 2 by 6, 3 by 6, 2 by 6. This is what? Come on. Yes, 5 by 6, 5 by 6. It's a less than 1, correct or not? Certainly, which lies inside the triangle OAB. First option is applicable. This is only to say where it lies in comparison with this point. We can assess, we can analyze the position of this point. You are not supposed to take 3 by 5. You are supposed to take L is equal to 3 by 6, M is equal to 2 by 6, L plus M is what? Less than 1. L greater than 0, M greater than 0, L plus M is what? Come on, less than 1. Go to, come on, first case. Then C lies in the what? Triangle OAB. So therefore, C lies inside triangle OAB. This is the first option. Next, if I go to this one is, come on, OC bar is equal to, now you take the what? LCM 3A bar plus 2B bar by what? 4. But I don't know exactly. If it is a ratio 0.5 must be there. Write down the what? Come on. This C is what? Greater than 3A bar plus 2B bar by what? 5 is equal to OP bar. Because P is a point, I written whose position vector is what? Known. To compare with OC, to draw the figure, to identify the position, we can write. So therefore now, because by 4 is greater than this, this is 5 is less than this. So therefore, you draw a what? Come on, triangle. This is what? Come on, A. This is what? B. Like this. Okay. Like this. Oh. Now, P is a point which divides. Look here. P is a point which divides. This is which divides in what ratio? Now this is 3:2, correct or not? So you can very well observe the point lies here, see. So therefore, now you can very well observe L is equal to how much? 3 by 4. M that is greater than 0. M is equal to what? 1 by 2, greater than 0. So therefore, L plus M is equal to 3 by 4 plus 1 by 2 is equal to, that is, take LCM, 3 plus 2 by what? 4. It's equal to 5 by 4. S greater than 1. Come on, case 2. Yes, case 2. L positive, M positive, L plus M greater than 1. Then the point C lies outside of the triangle OAB, but inside the what? Come on, angle AOB. Angle AOB. L positive, M positive, L plus M greater than 1. So therefore, C lies, that is outside of the triangle OAB, but inside the angle AOB. Yes, you can give your own examples and verify the position of a point with respect to A bar and B bar. A bar and B bar followed. So therefore, once again, now look here, when OA bar is equal to A bar, OB bar is equal to B bar, OC bar is equal to what? LA bar plus MB bar. It can be expressed as what? Linear combination, just like a what? R bar is equal to 1 minus S into A bar plus SB bar. It's a line equation. Line equation means it's a collinear points, correct or not? So therefore, line is nothing but a set of what? Locus of a collinear points, correct or not? So therefore, now by using the concepts, I given many conditions. Yes. First condition is L greater than 0, M greater than 0, L plus M what? Come on, S greater than 1. Okay, less than 1, less than 1. Then C bar lies inside the triangle what? Come on, OAB. Next, L positive, M positive, L plus M greater than 1. C lies outside of the triangle OAB, but inside the angle AOB. Then C, when L positive, M positive, that is L negative, M positive, L plus M less than 1, then lies outside the triangle what? OAB, but inside the angle OAB, right? Next, when L positive, M negative, L plus M is what? Less than 1. Then C bar lies outside of the triangle OAB, but inside the angle OBA. So therefore, these are the examples to decide what the position of a point with respect to the 2 points. Thank you.